Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over an introductory tutorial on differential equations. We're going to be looking at how to solve differential equations using the method of separation of variables. This standard is covered in calculus, differential equation, and physics courses. Don't forget, we have 2 practice problems for you to try out at the end of this presentation in order to ensure mastery of the content covered. If you'd like to gain access to our entire presentation, playlists, and other valuable resources, just take a look in the link in the description below or visit our website at mathgotserved.com. Alright, so the instructions are as follows. We are to find the particular solution, find the particular solution of the differential equation with the given of the differential equation with the given initial condition. Okay. All right. This is also known as an initial value problem. So for question number 1, let's say we have the differential equation dy dx equals 2 over the quantity x minus 2 square. And we have the initial condition y of 2. So y of negative 2 is equal to 5 over 2. Okay? All right, so first of all, how do we know that this is a differential equation problem? Well, anytime you have an equation that involves dy dx, you automatically know that it's a differential equation problem, okay? So to solve it, in this particular problem, we're going to be using the separation of variables method. Alrighty, so whenever you're solving differential equations, using separation of variables, we're going to be using the sci-fi method, okay? All right, so what does sci-fi mean? Basically, you separate and then you integrate the separated equation, and then you find c. And then after you find c, you're going to isolate y, the variable y, after you insert c back into the equation, okay? So separate, integrate, find c, and then isolate y. Okay, so let's do it. So first things first, we're going to go ahead and separate our differential equation. So what does it mean to separate a differential equation? Well, that involves placing all the y's, including the y, on the left side of the equation, and then putting everything else, the x's and the x's on the right side. Okay, now if you take a look at this differential equation, it's not too crazy complicated. You just have only one component with the y on the left side, which is just dy, and then everything else is on the right with a dx on the left. Okay, so in order for us to separate, all we just have to do is move the dx term to the right side of the equation using the appropriate algebraic procedure. Alrighty. So since we're dividing by dx here, to undo that division, we'll just simply multiply both sides of the equation by dx, and that will accomplish full separation. Okay, so we're going to have dy equals 2 over x minus 2 square dx. Okay, now that we're done separating, we're now going to proceed to integrate. All right, so what's the goal of integration? Well, it helps us to get rid of the dy and the dx components. Okay, so now what we're going to do is we're going to integrate dy. Imagine there's a coefficient here which is 1. So integrating 1 with respect to y, and then we can factor out this 2 times the integral of 1 over quantity x minus 2 square dx. Okay, All right, I like to integrate both left and right hand sides of the equation at the same time. Alrighty. In this particular problem, it's easy to integrate the left side, but the right side requires some work. If you take a look at the right side, we have a composite function, and the derivative of the inner function of the composite, x minus 2, results in a multiple of this tx right here. So that tells us that we're going to have to use the u substitution. Okay, so how are we going to do that? So from here, the u is going to be the inner function, okay, which is x minus 2. And then du, differentiate both sides, is just dx. So this is a perfect substitution here because we can just replace the inner function, x minus 2, with u, and dx can be substituted with du, sorry. All right, so it's always good to make sure you know exactly what's going where before you carry out your substitution. So we have the integral of 1 dy equals 2 times the integral of 1 over u du, 1 over u squared du. Alrighty, now we have carried out the u substitution, but we're not ready to integrate yet since we don't have any rule for a scenario like this. So what we're going to do next is we're going to rewrite this rational function as a reciprocal, as a power, okay, by implementing the reciprocal property of exponents. So rewrite as a power. Why are we rewriting this as a power? Well, so that we can use the power rule for integration that's easy to execute. Alrighty, so if we integrate 1 dy, it's going to be equal to 2 times, now if we reciprocate u squared, is going to be u to the negative 2 du. Now we're in business. Now we can make use of the u substitution. We can make use of the power rule for integration. Okay, all right, let's go ahead and do it. So if you integrate the left side, you integrate this, is going to be y. Okay, it has a plus c, but we don't put it in yet. Therefore, integrate the right side is going to be 2u to the negative 2, the power plus 1, over the power plus 1 plus c. Okay, so this c is a composite c. This c is a combination of the c from the left and the right combined together. Okay, all right, so we're going to have y equals 2u to the negative 1 over negative 1 plus c. Let's simplify this completely first, and then we have y equals negative 2 over u when you reciprocate the u to the negative 1 plus c. All right, now we'll have to resub the value of x back into this u in order to be able to find c. Why is that? We'll go over that in a minute. So let's resub. What did we say u is? U is x minus 2, right? Resub x minus 2 for u. When we carry out our resubstitution, we have y equals negative 2 over the quantity x minus 2 plus c. All right, so this is the integration part of the whole process. Now we are going to have to find c and then isolate y. The nice thing about this particular problem is y is already isolated in this form. So when we just find c, we just insert it here and we're done, okay? So just a side point, what we have right here is known as the general solution. All right, this is the general solution. But in this particular problem, we are asked to find the particular solution that satisfies the initial condition. Okay, so now I want to find the initial condition, the particular solution. So we need the c value to enable us to do that. So using the initial condition, y of negative 2 equals 5 over 2. We know, what do we know? We know that x is equal to negative 2 and y is equal to 5 over 2. Okay, so x is basically what you substitute into the function, and then y is what you get out. All right, so how does this help us? Well, we're going to plug in these two values into this equation right here to solve for C. Okay, so now what we're doing now is we want to find C using the initial condition. Okay, all right, so let's substitute it in. Y is 5 over 2, so we have 5 over 2 equals negative 2 over x is negative 2 minus 2 plus C. So it's just algebra now, just to get C by itself, okay? So we have 5 over 2 equals negative 2 over minus 2 is minus 4 plus C. So you slash and dash, reduce that. You get 5 over 2 equals 1 over 2 plus C. And then you subtract 1/2 from both sides. And then you have C is equal to 4 over 2, and that equals 2. All right, so there you have it. Now let's go ahead and write down the particular solution. We'll just substitute C into the general solution that we have. So substitute C into the general solution. If we do that, that will give us our final answer in this particular problem. So we're going to have, let's see, what's the general solution? Y equals negative 2 over x minus 2 plus C, which is plus 2. Okay, and ladies and gentlemen, this is the particular solution of the differential equation. Now, in some cases, when you carry out your substitution of C into the general solution to find a particular solution, some work needs to be done, okay? But in this particular case, this is an introductory example, so no work needs to be done. Just by substituting, you automatically achieve the particular solution, which tells you that you're done, okay? Now, how do you know that you have the particular solution? Once y is isolated completely, then you have your particular solution, alrighty? So there you have it. Now, what we're going to do next is give you some practice problems for you to try out to make sure you understand the whole process of solving introductory problems on differential equations. Alrighty, so here are the two differential equations we'd like you to solve for the particular solution using the method of separation of variables. So what we'd like you to do at this time is have you go ahead and pause this video presentation, solve these two problems completely, and click on the playback button in order to see what the answers are. Alrighty, welcome back. Hopefully you had a chance to try out the problems. The solutions to try these problems are as follows. So the particular solution to problem number 1 is y equals 1 over x plus 2 plus 1. And for number 2, the particular solution is y equals 2 over x minus 3 minus 2. Okay, so how well did you do in these two practice problems? Well, let us know in the comment section below how well you did, or if you have any questions or clarifications that you would like us to make to the whole problem solving process. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of differential equations or calculus in general, do give us a like or thumbs up. Your positive feedback is very valuable to us. As indicated earlier, if you have any questions or comments, just please post it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other future uploads such as this. We upload videos to our page on a weekly basis. And also, you can take a look at the link in the description below, or just visit our website at mathgotserved.com to gain access to tons of support resources to help you do well in calculus. Thanks again for watching, and have a wonderful day. Goodbye.